This example has a motor that is winding up a cord attached to an 80-pound crate at a constant speed. We need to find the force in the cord CD supporting the pulley and the angle for equilibrium. So we are given that the weight at A is 80 pounds. We have an 80-pound crate, and we need to find the tension in cable CD, this cable right here, CD, and the angle theta right here to make it be in equilibrium. So the first thing I'm going to do is draw a free body diagram. I'm going to draw my free body diagram of the pulley here. So the weight coming off of it, the weight at A is 80 pounds. And then we have the tension coming off here from B to C, and it has an angle as dictated by this 5, 12, 13 triangle. And just so you know, since it's around a pulley and it's a continuous string, this tension over here in TBC has to be the same as that weight because it's all in the same cable. So this we can just label as WA because those are going to be the same. It's just going to have different components because it's at an angle as compared to this straight down weight. And then we also have an tension in the cable TCD at an angle, unknown angle of theta. So this is what my free body diagram looks like. So then I could write my equations of equilibrium. Summing the forces in the x direction. Some of the forces in the x direction will be TCD cosine of the angle theta. We don't know either of those, so we'll just leave that there. And then we have the 5 component, the 5/13 component of the force WA acting there equal to 0. So just multiplying that out a bit, since I know WA is 80 pounds, I can multiply this out and get that TCD cosine of theta is equal to 30.77. And I'm going to call that my equation 1. Then I can do the sum of my equations some of the forces in the y direction will be TCD sine of theta minus the y component of this force, WA, which is the 12/13, and WA will be 80, minus 80 pounds, which is my weight coming down, and that's equal to 0. So multiplying these out, I have TCD sine of theta is equal to 12/13 times 80 plus 80. And so then I have TCD sine of theta is equal to 153.8. And I'm going to call that my second equation. Now I'm going to just do my algebra and solve for the things that I need to know. So the first thing I'm going to do is divide equation 2 by equation 1. So I'll have TCD sine of theta over TCD cosine of theta is equal to 153.8 over 30.77. And keeping in mind that makes it easy because I recognize that tangent of theta is equal to the sine of theta over the cosine of theta. So I can, these cross out, and I'm going to replace sine over cosine with tangent of theta is equal to 5. So then I can solve for theta is equal to 78.7 degrees. And now I can sub this into either equation 1 or 2. It doesn't matter. So I'll take TCD sine, let's see, which one am I taking then? We'll take equation 2, TCD sine of 78.7 degrees is equal to 153.8. So TCD is equal to 156.8 pounds.